And so he came up with a theory to fit the understanding of the universe that the ancient Greeks had at that time. So they believed that the universe was made of 4 elements, which I imagine some people watching or listening will know, but water, fire, earth, and air. So you've got 4 elements, and you've got 5 shapes. So at this point, Plato probably should have given up on the theory. But he was undeterred, and he decided, let's just pretend there is now a 5th element called the heavens, which seems fair enough. Sort of the heavens were seen as being different to Earth and different things. So now you've got your 5 elements: earth, fire, air, and water, and the heavens, 5 shapes. And so his theory was that.
And welcome to the Consciousness of the Way. I am your humble servant and Sifu, Taoist Master Sun Ching. And I've been looking forward to this conversation ever since this incredible guest accepted my invitation. I want to welcome to the podcast today Tom Roxbath, more formally a mathematician and a teacher, perhaps even a seeker of what does numbers really mean to the universe. I want to welcome you to the podcast, my dear friend.
Pleasure to be here. Pleasure to be here. Yeah. Seeker of what numbers mean. That is a new way of thinking about maths that I possibly isn't how I would personally have described it, but I think it's pretty accurate. It's kind of what we do with the study of maths. That's what being a mathematician is. It's trying to find order and patterns in the universe in a way.
Yes, yes. Well, why don't you share a little bit more about yourself leading up to this point?
Absolutely. So I sort of wear 2 hats, but both of them can be captured by I'm a mathematician. I teach maths. My sort of formal hat is I teach maths at university. So I'm based in Oxford in the UK, and I'm teaching undergraduate maths on a daily basis. It's brilliant working with all these incredibly intelligent young people. And really seeing them grow into adults, that sort of 18 through to 21, 22, I find is really when you kind of become an adult and the person you're going to be for the rest of your life. So that's really, as well as being able to teach the maths, that's really interesting to see that transition. And then my other hat, let's call it the slightly less formal hat, is, as you said, I teach maths on YouTube. Through my channel Tom Rocks Maths, and on various other social media platforms, mainly just trying to generate excitement and enthusiasm towards the subject of maths in whatever way that might be for you as an individual. That's sort of, I think, one of the ways I try to, or I would use to describe my approach, is to think about how does this person or this audience I'm speaking to, how can I present maths in a way that makes sense to them? It's not, because that won't be necessarily how it makes sense to me or how it makes sense to the last person I spoke to about maths. So my sort of main goal is, as long as I am able to get somebody to engage with numbers or maths as a subject, then I have achieved my goal. They will hopefully feel less anxious about dealing with numbers, about the subject, and maybe feel possibly more enthusiastic about trying to understand more around the subject.
Yeah. I mean, being a teacher is definitely a selfless job, quite frankly. Understanding that you are giving wholeheartedly your attention to someone else's learning curve. And from that, you have to have patience and understanding. I believe that comes in all forms. As a teacher myself, you have to approach it in a certain way that it will be a sort of a symbiotic relationship that you're pulsating back and forth and learning. You're throwing the ball out, someone grabs it, and then they throw it back to you, and we're getting a rhythm here. And I find that you're very, basically I would call it a contribution to the world's learning is really fascinating. And especially in this space, from a metaphysical perspective, from a quantum perspective. We're talking about numbers. Numbers are basically the foundation of all things when you start to get deeper into it. And I just find that fascinating. And so do you approach anything of that nature? Are you interested in sort of like physics or anything deeper?
Yeah, no, I teach a whole range of subjects. So I teach a lot of abstract subjects where we're thinking about higher dimensional spaces and trying to understand what that means mathematically, because of course we don't have the real world experience of what that means. So that's interesting. But I think that most of the courses I teach, and sort of my favorite ones to teach, are related to physics. So the idea of, like, I think of it as maths is the tool that we use to understand the universe. That's how at least it's a tool that I use to understand the universe. I'm sure everybody has their own way of trying to make sense of the universe. But for me, it's very much looking for patterns. It's coming up with equations that explain what is happening in the universe, and then try to use those to better understand what is happening, and therefore kind of, I wouldn't say bend it to your will, but obviously understanding how, I don't know, lift force works means you can fly planes. So there is an element of, once you understand like the rules of the universe, that's how I think about it. Like, the rules of the universe are written in maths, they're written in equations. And so once you kind of identify them, once you know what the rules of the game are, it's much easier to play the game. Is sort of how I would think about it. So no, I love exploring anything that is practical and is applied and has that grounding in like real life rather than the abstract stuff. The abstract stuff's also fun, but I think my preference is like around physics. And I do teach a course in quantum theory, with you mentioning sort of elements of that. But again, the way we approach it mathematically is very, it's a really interesting one, because all of the maths make sense to me as a mathematician, but then the results that it produces are really difficult to get your head around as a human who lives on Earth, because we, the quantum universe, this very, very small world inside individual atoms, it doesn't behave like our medium-sized world of humans and the Earth, and so like the rules of the game are different when you're on that really small scale inside individual atoms, and we think we know what's happening to an extent. And again, you know, this is leading to developments in quantum computing and other kinds of potential applications. But even though the maths and the equations make sense, again, to me as a mathematician at least, the results are still really hard to actually get your head around, because it's so different to our everyday experiences.
Wow. So I love this. So let's go a little deeper. What are the fundamental rules of the universe that you could sort of give us a summation of within mathematics?
Yeah, so it's kind of things that you've probably heard at some point during your education, most likely at school. So you can start with things like the way that gravity works. So the fact that every object has a mass, and the larger that mass, it creates a force that draws other mass towards it, which is a really weird thing to think about. But you as an individual generate your own gravitational field. It's just tiny because your mass is really, really small. But if you increase the mass to something the size of a planet, then you pull things back towards you. And that's like the gravity that we experience. You know, if you jump in the air, you come back down because the Earth's pulling you back down. But again, that's a rule of the universe that you can experience by just jumping. But the sort of the equation tells you that the actual understanding that doesn't link to your everyday experience, the maths behind it, tells you that even a human being creates a gravitational field. It's just that force is just so small that you would never actually like just have something be pulled towards you like the Earth pulls you back down to the surface. But it exists. So it's just a rule of the universe. Mass generates a force which pulls things towards it, and that's what we call gravity. We then got more complicated things. So you have like Einstein's theory of relativity, which talks about the speed of light being the speed limit of the universe. So it isn't possible, again, based on our current understanding of the universe, the top speed of anything ever is the speed of light. It's like the maximum. Nothing can ever go faster than the speed of light. And to me, that's really interesting, just to think like it's almost completely arbitrary. Like why is there a maximum, but yet there is. So there's a whole host of these kinds of rules. They're not written like rules of a game where it's, roll the die and get a 3 and do this. It's not as straightforward. But I think that's kind of what you try to do as a scientist, and what I try to do as a mathematician is you're trying to work out what these rules are. And that comes from experiences, that comes from testing things. It comes from saying, I think this is the rule. Can I test to see if this is true? Sort of coming up with a hypothesis and then trying to conduct an experiment to test it. Sort of, it's often referred to like the scientific method. So I'm obviously coming from a scientific background, I'm a very big believer in the scientific method. And sort of that's how I would think about the way we try and discover what the rules are for the universe.
Now, gravity, you mentioned gravity. It seems to be this struggle within a quantum model that's not really resolved, or they have a definition that it doesn't fit in. This is this part where you're saying it's like, hang on, it's a little bit more complicated than that. And then you get to certain points where, hang on a second, well, let's just throw that one out. We don't need that one. Where are we on that in the search and discovery right now, currently?
Definitely way beyond my area of expertise, but my current understanding is we have a model for the quantum world. So there are rules about how particles interact, about how atoms interact with one another, that we think we understand, as in we've tested it. This is why we spend billions of pounds building hadron colliders underground in Switzerland and various other things to try and test out, because you have to create crazy experimental setups to test out these things that we think, the theory that you think might be true. And all of the quantum stuff seems to hold. And then, so that's like on the really, really small scale. And then on like the really, really big scale, so like thinking of planets and stars rather than individual atoms, we then have the rules of relativity. So this is all the work of Einstein from 100 years ago about how really large planets and like the sun, for example, actually causes space-time itself to bend, which is a really weird thing to get your head around, but that's kind of how it works. And again, we've tested this, and that is what happens. So you have like rules that work on this really big scale, rules that work on this really small scale. And again, every time we've tested them, they hold. And then, like you said, in the middle, you kind of have like human-sized things. And that's where we experience gravity. And it's kind of like what you're trying to do as a physicist, or what we're trying to do as scientists, humans, I guess, understanding the world this way, is you're trying to tie together all of these theories. So I think the way it's kind of been done at the moment is to say, let's start with the rules of everything that's really small. So let's start with the quantum stuff that we understand, the quantum universe inside atoms. And there's no reason why the equations that are true there shouldn't then be true at, let's say, the middle part, human-sized things. And that pretty much works. We can kind of make that work. You have to slightly adjust for things, and over the last 100 years, physicists have been figuring it out. And you can make that work. But then going from the middle-sized stuff to big relativity planets and the sun, that doesn't work anymore. And that's the thing with gravity, because gravity is really key. Like the reason that the sun causes space-time to curve is because it has such a big gravitational pull. And it's crazy to think it's like it's pulling things so much that actual space itself is bending. So like that's what we can't make match with the quantum, the really small stuff. So we kind of have at the moment, you almost think about it, and we almost teach it this way, actually, that there's like these three separate theories: big stuff, relativity and Einstein; small stuff, quantum; in the middle, it's like gravity plus Newton's laws. So like all the stuff from 400 years ago. Because obviously that was the easiest one to discover because it's the stuff that happens every day to you as a human. But the really big stuff you can't discover or play around with until you're like in space. And the really small stuff, we needed like, you know, microscopes and hadron colliders, and you needed technology to advance to study the really small stuff. So now it's just about patching them all together. And like you say, gravity is proving to be a big puzzle that we currently don't have an answer for. We can't make it work and fit all of those three things together.
Yeah, it's from a seeker of things like a little bit more esoteric, like the stuff I teach, which is internal alchemy, Taoist practices and whatnot. We still fall back on numerology and understanding the stars, the constellations, and the human's relationship with the universe. But it still falls into what I have a question for you is, what in definition is a polymathematician?
So I think a polymath, from my understanding of the term, refers to somebody who seems to be very, very knowledgeable in a very big, wide range of fields. So I think I'm qualified enough to say that I am good at maths. having studied it for 17 years at university and teaching it, and being a doctor of mathematics, I think by all reasonable measures I can argue that I am an expert when it comes to maths. Now, I guess a polymath is often somebody who is very, very good in a whole range of different things. So they probably often, I know I have a few friends who are polymaths, and like they just have an incredible ability to recall random bits of information that they have heard once in their life, some point 17 years ago, and for whatever reason it just stays in their brain, and then they can like grab it and pull it out at the relevant moment to sort of answer a pub quiz question or to engage in a conversation with somebody on that topic. So that's kind of, I don't know the full psychology behind it or the neuroscience, but I imagine there's a strong link between people with a really good memory and what you would refer to as a polymath. Because it sort of feels like if you're going to be an expert in so many different areas of academic knowledge, then you're going to need to have a very good memory to store it all somewhere in your brain.
Well, I noticed you have a relationship at some point. I looking through your material, Platonic solids is something that you move through, or you teach, or maybe it's just something that you have your own obsession with. Tell us a little bit more about that and how you integrate that into your teaching.
Absolutely. I actually have a tattoo of the Platonic solids down my leg. I can send you a photo if you would like a photo. Maybe we can put it alongside the episode. The Platonic solids I find fascinating because to me, you can actually define them mathematically. This is how I think about it. And then I talk to, in schools, I do a talk about ancient mathematics, and I talk about the Platonic solids, because of course they go back to Plato. Even though it wasn't Plato who actually first thought about them. There was a guy called Theaetetus who first did the proof, the mathematical proof. So from a mathematical standpoint, the Platonic solids are defined by 3 rules. So it has to be a 3-dimensional shape. So it's not flat, it has 3D to it. Every face of the shape has to be the same regular polygon. Now, all that means is if one of the faces is a triangle, all of the faces are triangles. If one of them is a square, all of the faces are squares. But by regular, it means your triangle will be an equilateral triangle. So every angle is the same and every side length is the same. So it's a square rather than a rectangle. And as I say, it would be an equilateral triangle rather than an isosceles or some other type of triangle. So that's the second rule. So you've got 3D, every face is the same shape. And then this is the kind of technical one. Every corner of the shape has the same number of faces joining at that corner. So I'm looking around to see if I have a cube near me. I don't think I do, but oh, I do actually have a rectangular box, okay, which is going to act as a prop. So if you look at that corner there in my rectangular box, you've got this face, you've got this face, and you've got this face all joining. So 3 faces. Now, if I flip it and go to the opposite side, I'm going to attempt to try and show this again. You will get, there are 3 faces again. You got the one on the top, you got this one, you got this. So every corner, no matter how I rotate the shape, there's always 3 faces. That's true for a cuboid and true for a cube. So you can just check this if you look at any of the Platonic solids and pick one of the corners, count the number of faces. It's the same no matter which corner you pick. So they sound like 3 pretty general rules. 3D, same shape face, same number each corner. But yet the sort of, to me, the incredible thing about it is there are only 5 shapes in the universe that you can build that satisfy those 3 rules, which it doesn't, like, for there to only be 5, you feel like the rules should be really restrictive. But yet they sound really general. It's just saying, okay, well, if one face is a triangle, they all are. I want like 3 at every corner, and it's going to be 3-dimensional. It feels like there should be so many different ways to construct a shape following those rules. And it was this Greek mathematician, Theaetetus, who actually did a proof. He did it by counting the size of each angle at the corner, because it can never be greater than 360 degrees, and sort of use that as the basis of the proof. And it's really clever stuff. And he showed that there are only 5 you can build, and they are the 5 Platonic solids that we have. And I don't know if you know the story about how they then became named after Plato rather than Theaetetus.
Please share it. Yeah.
Okay. This is my favorite part of the story, because so Theaetetus did this work. He did the sort of the maths and to show that these shapes existed. Now, what those 3 rules ultimately lead to are very symmetric shapes. So they're very pleasing to look at, because no matter which way you look at your cube or your triangle-based pyramid, tetrahedron, whatever way you look at it, it kind of looks the same. Like no matter which face you look at. And that is very pleasing to humans, that kind of level of symmetry. We tend to like symmetrical things. So Plato heard about this work as a big thinker, famous person at the time. And he decided that he kind of became a bit fascinated by the shapes. And he felt like they had to have a higher purpose than just being a mathematical oddity. He said the fact that something so symmetric and beautiful, something that follows such simple rules, but there's only 5 of them, he sort of almost became a little bit obsessed and felt like there had to be a bigger meaning to these shapes. And so he came up with a theory to fit the understanding of the universe that the ancient Greeks had at that time. So they believed that the universe was made of 4 elements, which I imagine some people watching or listening will know, but water, fire, earth, and air. So you've got 4 elements and you've got 5 shapes. So at this point, Plato probably should have given up on the theory. But he was undeterred, and he decided, let's just pretend there is now a 5th element called the heavens, which seems fair enough. Sort of the heavens were seen as being different to earth and different things. So now you've got your 5 elements, earth, fire, air, and water, and the heavens, 5 shapes. And so his theory was that each one of the 5 elements is made of small pieces, and those pieces are one of the Platonic solids. And it kind of, given the current scientific understanding we have about the universe, it seems possibly a little bit ridiculous, because It's not how we currently understand the world. But I do really like Plato's thought process, because whilst we now know that, you know, the earth, meaning the soil, isn't made from cube-shaped pieces. He thought earth was cube. It is made from smaller pieces, which we call molecules, which are made from smaller pieces called atoms. So he wasn't a million miles away with this idea of the universe being built from smaller pieces, which I think is really neat, that even, you know, 3,000 years ago was kind of the very first beginnings of this idea of everything being built from smaller pieces in the whole universe. So yeah, so that's how they became known as the Platonic solids. They were then named after Plato because he then wrote about them in his book, and it sort of propagated this idea that each one of the 5 elements corresponded to a solid. Do you happen, so I mentioned that the earth was the cube. Do you happen to know what the others might be, or do you want to guess what some of the others might be? Because this is always a fun exercise to try and put yourself in the mind of Plato. Because there was some sense to it. So let's, how about if we think about fire? So you've got your tetrahedron, which is the pyramid. You've got your octahedron, which is the diamond shape. You've got the dodecahedron, which is the 12 faces with the pentagons. And then you've got your 20-sided icosahedron, which is 20 triangles.
So would it be the triangle? No.
It would be one of the triangle ones. So
right.
Plato's, there is some logic to it. So he said that fire is sharp to the touch, meaning it's painful. And so of the Platonic solids, the one that is like the most pointed, as in would be the most painful to poke, is the pyramid. It's the tetrahedron. So that was his argument. And then water, he argued water flows sort of in rivers and flows through your hand. And so it must be made up of the shape which is the most round. So it would roll the most more easily. And that would be the icosahedron, which is the one with 20 sides. And then he kind of ran out of ideas at this point. So he said the cube was earth because you can use it to construct things and build things. It's very easy to stack cubes on top of one another to build larger structures. And then the other two, he then, I'll have to try and remember what the quote is, but it's something like, air is the octahedron, one can barely feel its minuscule components, which makes no sense because any of them can be as big or as small as you want them to be. But that's what he wrote down. And then that means the dodecahedron, the pentagon, the one made of 12 pentagons, is the heavens. But someone pointed out to me, it was actually like a 13-year-old kid at a school who pointed out that he missed a trick because, again, ancient Greece, they have the gods of Olympus. How many gods are there of Olympus? There are 12. So it makes sense that your 12-sided dodecahedron would represent the heavens, where one face could be each god. But he did say that one was the heavens were the dodecahedron, but not for that reason. So I think he missed a trick. Actually, that would have been more convincing of an argument, and then you could say air was the octahedron by the process of elimination. But
yeah, it's interesting how shapes, you know, what contemporary spiritual seeking would be called sacred geometry, and you know, go into that. For Taoists, we've been using symbols, incantations, mudras, mantras, all that kind of stuff within our practices for thousands of years. And it always starts with, you know, something that will be a shape that has a vibration, and the vibration has a frequency. The frequency, if met with that resonance, you will manifest or create whatever it is. And that's sort of like the foundation of the mystical sort of construct of Taoist magic, Harry Potter stuff. But you know, it can be very powerful. Depends on what it is. You know, using the somatic sort of relationship that sound has integrated into these shapes.
Mm-hmm.
And so that understanding a little bit of, you know, epigenetics and the idea that, you know, there is a much deeper meaning within your DNA strand, looking at that, and some of the research that's come out in the last 20 or 30 years where they're using the periodic table to decipher the very code within a DNA strand and coming up with messages, sort of tends to have us question what is, you know, reality to some degree, because just the simplicity of sound creates this visceral experience that you can get. And then if you put it with a thought, feeling, and an emotion, that secret ingredient, all of a sudden you have your life, your experience, your past, your present, your future, all within these three ingredients. And they're all founded within numbers. And you start to realize, oh my goodness, wow, this whole idea that people talk about potentially hermetic principles or laws of the universe, as they put it, within Taoism, you are the universe is you, all is one, one is all. The understanding of this synchronicity that we refer to the nature of reality as being a bellows, and you are all things and nothing at the same time. You're contracting and expanding at the same time, which seems impossible. And then you go deep into the Death Star moment of Star Wars, where Luke Skywalker gets that one shot. And so that's the center point, which is within every shape is a center point. It all has this energetic profile, potential. And so when you start getting into the energetic potential, energy in of itself, which is pretty much everything, now you start to sample what you are experiencing as the truth through your physical body, the tuning fork, using your neurology to express that, you know, how you feel. Like the charge we just got a few seconds ago from aha moment we both collectively had is that, hang on, there's an attunement. Just now, again, you feel this going on in your body. Maybe you want to explain it, maybe you don't, but you just get this, you know, language that people talk about. You know, I lead with my head, I feel with my heart, I get a gut feeling. This is sort of a universal language that a lot of people don't even speak about, but they use it all the time. And it sort of expresses itself. And what you're doing is just phenomenal, because this is another way to have someone understand their reality through a validation, a self-realization, using the math to work out an equation that can then be summarized into a very science-based result. That this 1 + 1 = 2. And so the simplicity of it is humorous, but then you start applying it to the level of your understanding, and then all of a sudden people have aha moments through, I imagine, through your teaching, just sharing things about how you calculate that through the mathematical equations. You get this result, and then it could be applied on a small level and a large level, and then that in between. I mean, the stillness is what I would say a quantum physicist would call the 0 point, which is, you know, the point of contention, really, because it's still in a theory. The unified field theory is another one that's been floating around, which is another variation of what is the definition of quantum. But that 0 point would potentially lead us towards the event horizon of a black hole. And what does that really mean to the average person? Question mark. But then there seems to be some type of like weird adjustment, and maybe you can speak on this, that when you hit to that point, the electromagnetic potential changes. As you said, there's a bending within something like the sun. There's a bending of this reality, a bending, an altering of what's going on. Do you have any more insight into that, or?
I suppose it's something I find very hard to visualize, or actually explain exactly what does it mean to bend space-time. Because I don't think I personally interpret it as a bending of reality. I think I just see it as I sort of think of it as reality is sort of exists, and like the rules that we thought gave reality, so Newton's laws, don't work near the sun. So therefore the rules have changed there, and then the new rules about curvature of space-time and Einstein's work then explain what you're seeing near to the sun. So I suppose I think it's just it's obviously just how I think about things perhaps slightly differently, which is really interesting because I think it's just to do with that kind of difference in probably in backgrounds and like life experience, where I'm sort of very much like in a sort of scientific focused environment, as like I said, sort of trying to uncover what the rules of the universe are. So I think the way I would, I feel like I'm doing a bad job of explaining this, and maybe the way I would explain it is, if something happened that didn't fit what I thought the rules of the universe are, then to me, that would mean I have the wrong rules of the universe. So that would be really interesting. So then I'd be like, okay, so what are the new rules and how can I test them? Which perhaps is maybe slightly different to how you just explained kind of a changing of reality, which you could, I guess, using my language, you could say is, these are the rules of the universe. Something has changed here. So that means reality has changed. Whereas to me, it's just, oh, I've just discovered what reality really is. It's the fact that space-time bends. I didn't know that before. That's sort of, I think, how I would think about those kinds of questions in a way.
No, I love having these types of conversations because you do get to a point where I can be articulate and a little bit more expressive, but I share an experience. The most important thing for me is to show you a result. So within the energy, which technically from a scientific perspective, we didn't really know what electromagnetism was back until just the 1950s. So that in of itself is sort of an interesting realization for mankind. Yet from a more of a metaphysical, spiritual sense, that type of knowing has been going on for thousands of years. But it's like that, and people will say, well, sure, it has. I want to experience. I want to know. It's just talking words of, someone potentially who might be having a psychotic episode, or are you really able to value what and be able to explain and show? Where I love the way you're able to explain it and also help people break it down, and through your processes are able to understand it. You learn from these equations. You learn from the way that you're creating that knowing through the information you share. And so for me, I show people from an energetic perspective something that is visceral that can be validated by them. And so that is so subjective to the individual's experience that it varies. You say tomato, I say tomato, but moreover, there is what you would, as you called it, rules. There are rules and methods to this type of cultivation that will be repeatable. And that's what I love about math is it can be repeatable. It can be defined. You can focus right down to that last digit, that last dot, that last decimal point. That is, to me, really amazing stuff. And I think a lot of people don't realize the depth of how much that is applied. Like, as you said, quantum mechanics. How is that affecting our reality right now, because I can have conversations with people that are just Newtonian physics is it. And then the quantum model is gobbledygook, and I just can't get down with that because it just doesn't make any. It makes no sense to me.
It doesn't make sense. Yeah. I agree. There's the famous quote. I can't remember who it's attributed to, but it might be Richard Feynman, that says if you think you understand quantum mechanics, then you don't understand quantum mechanics, because it doesn't actually make sense with humans' experience. Because it's just, I think my favorite example, and I love teaching this to the students when we do this, is Heisenberg's uncertainty principle. So if you have a quantum particle, which often is talked about as an electron, so you have your atom, you have the center, the nucleus, which contains the protons and the neutrons, and then around it you have these electrons. They're often described as like flying around. It's not quite like that, but that's a nice picture to have. And an electron is a quantum particle. Now, the rules of quantum and this Heisenberg's uncertainty principle will tell you, and again, this is, to me, I can prove it mathematically, and so therefore that to me is enough proof. I'm sure other people will have different bars that must be cleared for proof, but for me as a mathematician, I know how to prove it, and so therefore I believe it to be true. If you were to measure the position and the velocity of your electron, so if you sort of compare that to our world, it's like saying I have a tennis ball and it's swinging around on a piece of string, like that the game you used to play in the back garden as a kid, or I used to play. And as it's moving around, any sort of frame in time, you know exactly where the ball is and you know how fast it is moving. You can just measure it. You can see like it's there and it's moving in that direction at 1 meter per second. You know, if you have like a speed gun or something to measure it. But with a quantum particle, you can never know those two things at the same time, which is just, it just doesn't make sense, because that's not how our world works. So that's why it's really hard to get your head around, because the Heisenberg's uncertainty principle says the more accurately you know the position. So if you know exactly where your electron is, you have no idea how fast it's moving. Or if you know how fast it's moving, you have no idea where it is. So, which is just a really difficult concept to actually get your head around as a human, because our world doesn't behave that way. So it's, yeah, I think that's why it's so difficult. And that's why for lots of people, it's, I think it helps for me that I'm able to do the maths and the equations behind it. And that to me, as I say, gives me enough belief that the equation is true. And therefore, if the math says it's true, I believe that. Because I spend all day, every day trying to do maths and solve equations, and everything else I get is true. So just because that thing can't be easily tested and I can't experience it, I have no reason to not believe it, given that everything else that you can prove mathematically is also true.
So would you say that, yeah. I'm sorry, would you say that the entanglement is validated through the numbers?
Yeah. We talk about entanglement in the course that I teach. Again, it exists. It does. It's sort of when you have a quantum particle, it just doesn't. It's really difficult to believe that this happens, because this isn't how our world works. But if you have a quantum particle and you measure it, so you decide, okay, there's this quantum particle whizzing around, I'm going to measure something about it. By measuring it, you cause it to change state and cause it to do something different, which again, really weird concept, because it's like there's a tennis ball flying past me. I'm measuring its speed. It doesn't care that I've measured its speed. It just continues to fly past me exactly as it was before. But a quantum particle would now do something different. You have changed it by measuring it. And that is how I think about entanglement in a nutshell, because it means that any quantum particle at any point in time has several different measurements that you could get. And only by actually measuring it do you get it to collapse onto one of those states.
So this would refer to that, I think, was it the double split experiment or something of that nature? Was that showing if you focus on something, it all of a sudden is materialized.
Yeah, so the double slit is showing that light can behave both as a wave and as a particle, which again is a really hard thing to get your head around, because you're like, well, it's got to be one or the other, because they're clearly different things. But yet it's sort of is hinting at quantum weirdness, that this idea that, yeah, like you say, it behaves in the way that you kind of measure it to behave. Yeah,
as long as you it's like the second you put your attention to it, it's created, in a sense. If you were to look at it from a holographic model, if that's something you believe in, that holographic theory of the universe, then that would be potentially just a very layman version of it, right?
yeah, possibly, yeah.
It's just like, hey, if all of a sudden it's materialized, supposedly. What are your thoughts on that? Do you put any weight to this holographic theory of reality? It's that everything is virtual.
I don't think I believe it, but I can understand why it is an appealing, or it is a plausible explanation for the universe. Because even with what I've been talking about around, there are rules of the universe, there are laws that you're trying to discover as a scientist. Like, so then you can ask the question, well, where did the rules come from? Like, why are they the rules? It's almost like, it's almost like saying, who wrote the rule book, in a way. Because, if you're trying to, and I think it also, because if you think about, as a human right now, if I wanted to create a virtual reality world, I write a series of rules in code, in binary, on a computer, but I literally write down what the rules are and then just like press go, and then it does whatever according to those rules. So it is, I can sort of see, again, I don't personally think it's true, but I also feel like it's one of the more believable theories around the universe, because of it does tie into what I believe around like trying to discover the rules and the laws of the universe. So then it is a perfectly valid question to ask, who wrote them? Where do they come from? I don't have an answer to that. I don't really think about that. I don't think, as a mathematician or a scientist, I'm just more about, for me, it's interesting to just try and discover what they are first. And I think by discovering what they are, then you might get hopefully you get more of an insight into perhaps where they came from. That sort of would be my approach to it. I think it's how I approach any problem in life, is the more you can learn about it, the easier it is to answer that question or solve that problem. So, the question of where did all the universe come from and who wrote the rules, which is a perfectly valid question to ask. Then I guess my approach to try and answer that would be, well, I'll try and figure out what all the rules are. And then once I know what I'm working with, maybe it will point to an obvious sort of starting point, which could well be the whole thing's a simulation. Who knows?
Yeah, it's it doesn't get you all warm and fuzzy inside. There are some things that excite me, and some things that do not, and it just sort of the same thing. What inspires you to look further, go deeper into whatever it is you're exploring, what you're experiencing, what you're learning, as you put it, learning. And I mean, the simplicity of just you and I having a conversation, and the fact that our mirror neurons will replicate each other's behavior, and you quite easily can absorb an event, a situation. A classic example is if you're at a football game, a concert, something else, there's this symbiotic relationship that takes place, and everyone's connected. And so that would then be sort of like, oh, well, is that part of like the quantum model? Well, technically, I mean, that's how you could experience it and go, well, isn't that what's going on, where everyone's connected to some degree? Does that make sense?
Yeah, no, it makes sense. I think for things of that nature, I think I would be more tempted. And this did come to mind with something that you mentioned earlier, actually. I'm possibly, would be more tempted to link it to sort of the evolutionary behavior of humans, where it's often, I think sometimes we forget that it's taken millions or billions of years for us to become the species that we are today. And so there are so many elements of our behavior that are linked to things millions of years ago that meant that we survived as a species. And I think that kind of herd-like behavior of in a lot of situations, and you would see it a lot in the animal kingdom as well, where when you have large groups of the same species, they all tend to kind of fall into line and copy one another's behavior. There seems to be something there that kind of like herd mentality seems to have like evolutionary benefits, I think, in terms of the survival of your species. So that would possibly be how I would experience the I guess like a crowd behaving in a certain way and things, but it's very difficult to actually design an experiment to determine what it is that's causing that behavior. So to sort of go back to what I was saying earlier about I'm a very firm believer in the scientific method. I guess it's an interesting question to be like, how could you try and measure things of that nature? As you say, maybe there is some kind of connection and some kind of unconscious signaling between humans in large crowds and other creatures. I honestly don't know. But it's
have you heard of something called heart math?
Doesn't ring a bell.
Should take a look at it. They've been studying the human heart and its relationship and the magnetic basically the magnetic potential and what it does in relation to, the macro of the micro, the earth having its magnetic field, the human having its magnetic field coming from that center point. And then, how when we measure things like the Schumann resonance and being able to, realize that there's this certain consistency that of hertz that are being transmitted on the earth at a specific point. If you're standing on planet Earth and the circadian rhythm of your day relates to where the sun's position is and all the rest of that good stuff, there is that correlation. So if you don't submit to the ups and downs, the ins and outs of your emotional state, you can maintain this resonance and mirror what the earth is transmitting and within yourself. And so they measure this type of stuff. And, this is far more in line with a lot of stuff that I've been teaching and has been around within Taoism for thousands of years. It's that idea that, that everything is inside of you, outside of you, and we're all together, right? Returning back to this idea of the quantum entanglement theory. So, from a psychologist perspective, what you would call a herd mentality is a psychodynamic loop. You're getting this sort of rapport and it starts with that magnetic field that you're projecting, and it connects with everyone else's. And then all of a sudden you have a thought form and someone else thinks the same thing. And you're like, well, how is that possible? And they just measure it in that sense of the word. So they've been measuring that for many decades. If it happens to have that same word that you love a lot, which is math. So heart math.
Yeah. I'll check it out. Yeah, I've not come across that, but no, I'll have a look. That sounds interesting.
That would probably answer a lot more questions you might have about how that's possible from a neurological perspective, using the neuroplasticity of the human body. We talk about this connecting the heart and the brain, and so you synchronize and create a coherence because there's a landmine of neurons that are also in the heart that are in the brain. So it represents equivalent to a small brain in your heart, which they're starting to correlate this information as being the heart is more the commander in chief than the brain itself, which is mind-boggling to most people. They don't, they can't even possibly imagine it. But from an esoteric, ancient practice, indigenous practice, we've been connecting these 2 points, the brain and the heart, within energetic potential, which someone might refer to as, the chakras within Taoism. We call them dantians, and you connect these, and when you connect them, all of a sudden you create coherence, a fluidity that takes place, and then you're instantly in charge of the state that you're in. So your emotional state is then not being hijacked by an event throughout your life that will probably reflect on some potential event that took place in your past that keeps reoccurring over and over again. Every time you have that event, someone jumps out and says, boo, you're afraid. And so that now embodies this sort of energetic potential within you. And so it presents itself. That's how people have all these emotional states. And from a psychological perspective, 14 different emotional states every day. They alter between them. They're like very interesting personalities. They don't even realize they're slipping into one to another to another. Oh, I'm just great. I'm fantastic. Well, 3 minutes ago, you were about to lose your mind on something, and now I'm just happy. I'm dancing through the roses. So, there's these sort of like evidence-based experiences that start to add up. They give you a little bit more of an understanding. And from that group mentality, it's actually the mirror neurons at the base of your brain that replicate whatever you're around. And so you can literally learn something. And what's a great example of that? The 4-minute mile. The second someone broke that, it literally within days, within weeks, people around the world were breaking that record that thought was impossible, the potential of it from a human being perspective. So that, again, is this sort of layered effect of making it valid for you as the experiencer. And that's why I love everything that you do in relation to what you teach people, because it's part of it is an experience. Tell me if I'm wrong in saying that math is an experience, and it's an experience to embody that, and your love for it, you get this visceral response to it. When you're aligned with something that you love, you enjoy it. It's kind of like I look at people that are accountants, and I honestly would rather throw myself off a bridge. Yet some of them will look at me and go, I love numbers. I love accounting. I love the experience of crunching that all together and making it happen. And so when did you realize this was the thing that made you, all warm and fuzzy inside? What age was it obvious to you?
So I have a memory from when I was like 7 or 8 at school and doing long multiplication. So when you multiply together, let's say two-digit numbers, you might have to work out 13 times 11, for example. And sort of you write them one above the other, and then you like carry, you kind of do like a diagonal thing. There's different methods to it, but I remember learning that for the first time. And we were set, I don't know, maybe 10 questions in the book as homework, but I was having so much fun that I just like sat there for about 5 hours and did the whole book. Because I was just enjoying it. I just thought it was really fun. And, like to then check the back and see if you got the right answer, and, to kind of have that almost like immediate gratification as well of getting it correct. Well, besides assuming I did, was kind of, I remember that is a memory I have from, as I say, being 7 or 8. But I think I've kind of always enjoyed maths, because the way I describe it to people is my brain does kind of work in patterns. And I think maths really is just the search for patterns, whether that's patterns in the universe to try and understand what the laws are and what the equations are, or patterns in numbers, or patterns in data, whatever it is, maths is the search for patterns. And then obviously, trying to understand why the patterns are there and, predict them. So I think that's just how my brain works. And it's definitely how it works now. And I don't know whether that's a product of having done maths for so long, or whether it's just always sort of wanted to work that way. And then when I discovered that's what maths is, it just sort of felt like a natural calling and just felt like the right way for me to think about things. But the situation I usually use to describe this is like, let's suppose I'm on top of a mountain. You know, I've just climbed a mountain, and you can picture yourself being there. And I absolutely will look around and, you know, breathtaking views. Maybe you're above the clouds. Maybe you can see forest or snow. And just like anybody else, I'm definitely thinking nature is incredible. This is breathtaking. This is, you know, you feel almost like quite insignificant compared to nature, but you also appreciate the beauty of everything. But then, you know, if I'm like imagining sort of doing like a panoramic view as I'm moving around, if I then see another mountain in the distance, I think most people would just be like, oh, there's another mountain over there. That's a nice view or whatever. But like something in my brain would be like, so how far away is that? And does it look taller or shorter? And can I like work out the angle that I'm looking at it? Like, I'm not actually doing the calculation because it would absolutely require a calculator and pen and paper and drawing diagrams. But it's just the fact that that's just where my brain would go. So I think it sort of possibly gives you an insight into how my brain sees the world. It's not that everything I see is numbers and equations and patterns. It's not like The Scene in A Beautiful Mind or anything like that. I don't think anyone actually sees the world like that. But it's just more that after I definitely have that appreciation of nature and the views and whatever else it might be at the top of the mountain, but also something in my brain wants to also try and figure out what else I can learn about it in like that mathematical sense. And that's not like a conscious thought I have. It just happens.
Like just effortlessly.
Yeah, again, it's not effortlessly that I'm not getting the answer, but just when I look in, you know, again, I'm looking at Mount Peak in the distance, my brain just would just go to, can I work out, is that mountain higher or lower than I am? And how could I work it out? Which is very much a mathematical problem.
Yeah, yeah. Have you ever thought about measuring your brain waves, or that didn't go there on that one?
No, I've never done anything like that. I know one of my friends recently got a 3D scan and then a model made of his brain, which he said was a very cool experience. So, but no, I've never had any kind of tests or anything done around that. I do remember doing one psychological test a good number of years ago. So I used to work as a science journalist for the BBC, and we were covering a story around it was in a publication by a neuroscientist, which looked at how the your brain type, as it was referred to, was linked to your taste in music. And it was just a relatively simple questionnaire on various statements, and you had to just like a sliding scale, and obviously at one end was what were called empathizers, which is people who tend to have a lot of empathy and work a lot on emotions. And at the other end of the scale, you had systemizers, where everything is very logical and follows, you know, the next thing you do is kind of the obvious thing to do based on what you've done previously, which is very much how maths works and how a mathematician thinks. So there was no surprise that I scored extremely highly on the systemizer elements of the test. And as a result was meant to like heavy metal music and classical music, which I've never really listened to classical music, but I do listen to heavy metal and things of that nature. And then it was quite funny because the researcher then played me a piece of music I was supposed to hate based on something that someone who scored really highly on empathizing would sort of listen to, and it was like an acoustic guitar love song thing, and I was like, yeah, that's not my vibe. So that's the closest. That's the one I remember doing that looked into a bit, sort of how my brain works. But beyond that, I've never done any kind of.
I'd be safe to say this with great confidence that you operate in a high gamma brainwave most of your conscious breathing moments, which is a highly evolved and conscious state in the sense of your ability to access all brainwaves at once, at the same time, individually, which then puts you in a position where you can change and alter your unconscious process and make it, you know, simplistic things from a hypnotherapist perspective of erasing PTSDs, changing behavior and patterns from getting into a deeper, you know, learning state, theta brainwave, while you're in gamma. And that's about the only time you can achieve that, when you're in a gamma brainwave, is you can go into those other brainwaves and actually transmit them. I find that I measure my brainwaves anywhere from 40 to 400 hertz whenever I'm witnessing a physical healing or energetic potential that goes up and beyond what most people would call normal. They call it probably paranormal or superhuman or whatever. But I've witnessed this over and over again and measure my brainwaves always coming in at that state. And, you know, most people start off with beta and they just get deep in their day, and a couple of coffees later and stress and this and that, and they're just a mess by the end of the day. They're begging for that melatonin to be spliced off and put them to la la land, and they do it all over again. And I think that, you know, your mastery of what you do, like anything, as you start to embody whatever it is that you're on the path for absorbing or learning, you create these new information energy highways, synapses in the brain that gives you that ability. And I think it's really awesome. But you become more efficient at whatever it is that you're doing. The more you embody it, the more you do it. I feel like it's completely different than just physical stuff. Like if you're just building your, you know, muscles or losing body fat or doing things of this nature, there's a shelf life or an ability to maintain that. Whereas something like what you're speaking of and what you're teaching people using the tools that you do, that's something that you can learn and you embody it within your neurology, and you can call on it at will when you start in training yourself, and it stays with you. It doesn't leave you. You actually get better at it. You can take a pause and come back, and you're even more mastered at that same skill, as opposed to like lifting weights or things like that, where there's literally, you know, if you take your foot off the pedal, you know, you put on the 2 pounds, you lose your strength, you know, there's a myriad of different things that take place from that, as opposed to the things that you're teaching people, and it never leaves them. Do you have a specific technique of how you do it as a teacher to get into, so that people will remember? They'll actually not just remember, but learn this stuff. It's about learning, right?
I definitely tend to favor getting them to really understand why we're doing, you know, why is this equation relevant in this setting? Why is this the approach to proving this theorem? So I definitely, I think most teachers, though, at least the ones that I know, try to, you know, your goal as a teacher is, wherever possible, you want to focus on that understanding rather than that memorizing, which I think ties into kind of how you were just describing it. It's sort of a situation of, rather than just learning the formula, if you truly understand where it's come from and why that formula exists, then you don't need to remember it, because you can derive it yourself when you need it, for example. Possibly not as efficient, but that kind of actual understanding of something. And I think that's sort of touching a bit on some of the stuff we were talking about earlier. I remember this came to mind. Like, it's those moments that you have with the students where we've sort of done something and we've gone through the maths, we've solved the problem, and then it feels like it then fits with their reality and their experiences. They're like the most powerful bits of maths that I find the students understand, and it feels like they're the ones that they really remember and sort of take with them. So, because we were talking about quantum theory earlier, for example, like, you know, we spend 4 lectures and several classes going through this really long derivation, starting from very, very like mathematical principles, nothing at all to do with quantum particles. And eventually you build up, and then you get to this result that tells you an electron on a hydrogen atom is some distance away. That's what the maths predicts. And then when you like look up in a physics textbook, how far away is an electron in a hydrogen atom based on experiments, it's like the exact number that we just got from the maths. So like, it's those kinds of things where you've approached it from a purely theoretical point, and then the answer you get perfectly matches like the reality and all your experience. And I think they're the most powerful teaching moments. And also I think they're the most sort of powerful results that you get actually, and the things that I enjoy teaching the most, because you can really see it making sense because it fits with someone's experiences.
Right. I mean, it's so funny how the elegance behind what you're talking about, and so you're speaking on things that have a feeling, an experience, and you're validating that the individual validates that through that synchronized knowing, that aha moment. Mm-hmm. And it makes sense to them when they've actually mastered and understood how that works. And then now you can use it in any form. You know, I mean, some people use, you know, you've probably heard of neuro-linguistic programming, and, you know, that understanding of using language to help people. You know, I could literally put a metaphor together and literally in the same second have someone who's deep within a PTSD they've had for 40 years, and within a few interesting stories, parallels, it becomes realized within themselves. And that's that neurological aspect that makes it sort of realized. So, you know, you get this sort of aha moment, a knowing. Yep. And how you put it, I think, is a really, really, really powerful way. Learning is that evidence, and then being able to apply it. So what was Yoda's famous one-liner? There is no try, only do. Something of that nature.
Yeah.
Well, this has been a really very fascinating conversation we've had today, my dear friend. And
it's made me think a lot, which is what I was hoping, and I'm very glad that has, that it's sort of gone that way. It's definitely, I think, as when we were talking before we started recording, you know, I sort of said I am a big believer in just, it's, you know, this isn't something that perhaps I would normally talk about, but I found it really enlightening, and I felt like I've just learned more about what you do, possibly what your listeners and viewers and engage with and think about. And I think I'm just like addicted to learning, whether just learning about everybody and everything. I just really enjoy hearing other people's perspectives and just, you know, trying to not be opinionated in myself, or I obviously have opinions and beliefs, but just realizing they are my own ways of making sense of the world. If somebody else wants to make sense of the world in a different way, then that's up to them, and that's perfectly valid and really interesting to hear. And I feel like it's been, I think it's been a really interesting discussion, and definitely I've enjoyed it, and definitely has made me think. So thank you.
You know, I also welcome a future conversation about something a little bit more that you could enlighten the audience with, a specific sort of problem, and solve it using that magical math to really.
I'll have a think. I'll have a think. I'll see. As I say, I'm sure I can come up with something. I'll see what I can do.
Yeah, no, I really, it's really important. I mean, I don't know how deep you've gone into any sort of things like, I mean, because you really love the shape itself and what it represents, shapes, lines, what that relates to in numbers. But like the pyramids, people are very obsessed with, and they're like cut to a certain angle and degree, and the numbers just line up, and people are perplexed by how that's even possible. That something that supposedly is made by hand is perfect. Have you got any insight into that, or?
I suppose the I tend to fall back on, it's kind of like similar to what I was describing earlier about the shifting reality phrase that you used and the bending of reality, because to me, that if there is evidence, if the evidence in front of you is suggesting that the angles and the carvings and things were too perfect and too accurate that it couldn't have been done by hand, but then I guess you would then look for evidence of tools or whatever it was that might have existed. But if you can't find that, then to me it feels like, what's the other explanation? But I suppose it just means that maybe there's something else you haven't thought about. That's often, because that was kind of like what relativity was when we were talking about the bending of space-time. You know, until Einstein decided, oh, that works, everyone thought he was crazy. They're like, space doesn't bend. What are you on about? That's, and then it turns out that, you know, you can do experiments in it and it does work. So maybe there's another creative solution that that you can find evidence for. But yeah, I wouldn't say I know enough about the history or the archaeology of the pyramids. I did visit them and they're awesome. Strongly recommend anyone, if you get the chance to go, it's definitely worth it. They are really quite spectacular to see. And I actually made a video about the maths of ancient Egypt, which is kind of fun, looking at how they use numbers and the geometry that they were doing. For example, like designing the pyramids, because they did know a lot more stuff than, say, Europeans did in the Middle Ages, when we decided, the Dark Ages as they're known. They were doing smarter stuff than we were back, you know, several thousand years later. So it wouldn't surprise me if they had some very clever way of doing it that we just haven't thought of yet.
Yeah, that's the unraveling of that mystery. And people get a lot of polymaths. They get into working out what that is, the meaning of life, you know, right down to the numbers that are so relevant, you know, the 12, the 7, the 3, the 6, the 9. For a Taoist, it's always in the number 9, the answers to all things, the creation of life from just basically a dot to a heartbeat to actual human flesh, all created within this 9-month period. Yet it's very symbolic from a cosmology perspective within Taoism, that we talk about the creation of the cosmos using this cycle, and it all starts with 9 and ends with 9, and that mirroring effect is, you know, as above so below from a hermetic principle. And that inner outer stuff, and that works within Taoist sort of like energetics and Chinese medicine, which was founded from Taoist alchemy. And so there's this understanding of the meridians and how that, you know, something as simplistic as reflexology is being able to tune all the energy in your body by using your hands or your face or your foot. And you have this sort of like mapping of all the ins and outs of what's going on in your physical body using this process. So it's sort of, it continues the excitement of wanting to learn more. We're all always on a path. As a Taoist, we always say the teacher is the student is the teacher forever. The second you lose sight of that, your consciousness stops. It ceases to continue. It just ends. And so I will say this. I'm going to put all your social media under this podcast. And I want people to come and find you. On my students, my OGs, the 126, the subscribers, all these. I want everyone to come and check your channel out and all the incredible stuff that you're putting out there. Do you have any other offerings to the audience? I know you are a full-time, teacher.
Mm-hmm.
Do you offer any sort of like little modules or programs that you can get through your social media that gives people a better insight into math? Or
so I think all of the stuff on my YouTube, there's literally like 350 videos on there now. And then my website as well. So I post like 3 or 4 things a week, which can be a whole host of like articles or podcasts or whatever to go with the YouTube videos. So there is a lot of stuff there, which I think is a great place to start. But if people are looking for like a formal maths qualification, I did actually recently join the Department for Continuing Education at Oxford. And so the department, we're like lifelong learning. So I've just finished teaching a course, but I'll be teaching it again next year. It's a maths course. It's like university level. So but there are beginner courses available. But you can, if it's of interest, there are like several hundred courses you can take online from anywhere in the world at Oxford University, and you will get a certificate to say you took a course at Oxford University. And they're in everything. There is really interesting stuff on archaeology, on ancient civilizations, on languages, on psychology, neuroscience. I obviously teach the maths based courses, but there's all my colleagues are amazing. I can't believe the range of courses that we offer. And then they're all open to everybody. There's no like prerequisites, as long as you have to pay, but it's very reasonably priced, in my opinion, given you're doing a 10-week course at the University of Oxford. So yeah, if people are looking for something more formal and certified, then I would recommend checking out that as well.
Well, in closing, my dear friend, I will ask you one last question. What's your definition of consciousness?
Oh, that is a good one. I've been to a few talks on this, actually, and I've never really been convinced by how other people try to explain it. How would I explain consciousness? Definition of consciousness. I think for me, it would come down to the ability to think for yourself, original thought. So it's not just being able, because that's what what computers can't do. They're very good at feeding them lots of data. They're very good at finding the patterns and then putting all that data together to then produce, a Shakespeare poem that you would think was Shakespeare. But that's just taking all of the stuff that he's done and just mashing it all together. But to come up with a completely new original style of poetry never seen before, that to me is a very human endeavor, and therefore by extension I would argue that's like how I would define consciousness. So that to have original ideas, original thought, and think for yourself. That's how I would do it.
I absolutely love it. I mean, I've had the pleasure of having this conversation with hundreds of people, and I've never heard the same answer.
I can imagine. Yeah.
I love that. And then, as it should be, for me, it's realizing you have choices.
Yeah. Absolutely.
Yeah. Well, this has been a pleasure, my dear friend. I really appreciate you accepting my invitation, and the conversation today has been really powerful. And I know the audience is going to really appreciate your insight, your mastery, and I want people to go deeper on all the stuff that you put out. It's instantly you learn stuff. Just being around you learn. It's like instantly learn it.
Yeah, I will force you to learn maths. That is true. I will force you to learn to think about maths in a different way. Yeah, absolutely. I can guarantee that. Yeah.
And so I want to thank you for sharing your time with me today. I want to thank the universe for bringing you into my life. I want to thank the audience for sharing their time with us today. And I am your humble servant and Sifu, Taoist Master Sun Ching. And I'll see you in the next one, guys.